Hi, fifth graders. Today's topics we're going to be reviewing greatest common factors, lowest common multiples, and some word problems. So let's get started with some greatest common factors. List number 3. It gives us two numbers, 35 and 28, and it wants us to find the greatest common factor of the two numbers shown. So we need to find the number that is for both 35 and 28. So let's list the factors of 35. So 1 times 35 can equal 35, of course. 2 cannot go into 35. 3 also cannot go into 35. 4 cannot go into 35. 5 can go into 35. 7 times, right? And we said that 1 times 35 is 35, so let's put 35. Now let's move on with 28, because for 35 it ends with 1, 5, 7, and 35. So all numbers have a factor of 1 in itself. So 2 can go into 28. We know that there's going to be a 28, but I'm going to write it down again a little later. So 2 can go into 28. 2 can go into 28. Let's try it out. Oops, sorry. That's not right. 0, bring down the 8. 2 can go into 8 4 times. Minus 2 can go into 28 14 times. So let's put 14 right there. 3, let's see if 3 can go into 28. It seems like it can't. It seems because 9 times 3 can go into 27. So probably can't go. 4 can go into 28. 7 times, right? And then we said it goes into 28. 1 times 28 equals 28. So now that we have all the factors down, we just need to find the number that they all have in common. So we can see that there's 1 in common. They have 1 in common, and they have 7 in common, and it seems like that's it. Even though 1 can be an answer, in this case, 7 is the greatest of the two, so we're going to say that 7 is the GCF. So once again, for GCF, you find the factors of both the numbers given, and you find the greatest factor that is common amongst those. Don't worry, we're going to do another practice. Let's do 50. So 1 times 50 equals 50. 2 times 25 equals 50. I don't think 3 can go into 50. 4 also cannot go into 50. 5 can go into 50, because 5 times 10 is 50, right? 6 cannot go into 50, 7 cannot go into 50, 9 cannot go into 50, but 10 can go into 50. 2 times 25 is 50, and then 25 times 1 is 50. Oops. So those are our factors of 50. Now let's find the factors of 65. So 1 can go into 65, of course. 2 cannot, because it ends with an odd number. Let's see if 3 can go to 65. So let's see, 3 can go into 6 2 times. 6 minus 6 is 0. Bring down the 5. Oh, it looks like 3 cannot go into 65, so we're not going to put 3. We know 4 cannot go into 65 because, once again, it ends in an odd number. However, we know that 5 can go into 65 because it ends in 5. And let's try it out. 5 goes into 65. 5 can go into 6 once. 6 minus 5 is 1. Bring down the 5. 5 can go into 15 3 times. 15 minus 15 is 0. We're left with no remainders, so we put 13. And we said that 1 times itself is always going to be a factor, so we're going to put 65. And that looks like that's it for the factors of 65. Now, once again, we're going to look for numbers that these two numbers have in common. The two factors that these two numbers have in common. Once again, there's 1, like always. And it looks like there is a 5. And since we know that everything has a factor of 1, we're going to discredit this, and we're going to go along with the 5. So our 5 is our GCF for our numbers of 50 and 65. Now I'm going to move on to these common multiples. So for this one, we're just finding the multiples of these two numbers and trying to see the lowest multiple that these numbers have in common. So in some cases, there will be that the lowest common multiple will be the number times the other number. That's the easiest way, and that seems to be the case for 14, because remember, multiples of 11 are always just like, if we multiply 11 by like 2, then it'll just be 22. 11 times 3, 33. So it's just like doubles of the same number. So in this case, it seems like since 9, the only time it'll be doubles of the same number, because let's try like 1 times 9 is 9, 1 times 2 is 18. 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, and it goes on, and they're never double of each other, right? The numbers are never doubles until 9 is multiplied by 11, which then it becomes 99. And since that's going to be the lowest, because once again I told you 11 times any number is just double the number, so it's our least common multiple will just be 99 for this case. Now this won't always be the case, but in special cases like this, that will be 99 will be our answer. Now let's move on to word problems regarding the last 2 lessons we just went over. Lesson number 2. Oscar needs to ship 14 rock CDs, 12 classical CDs, and 8 pop CDs. He can pack only one type of CD in each box, and he must pack the same number of CDs in each box. What is the greatest number of CDs Oscar can pack into each box? Wow, that was a tongue twister. So it says 14 CDs, 12 classical CDs, and 8 pop CDs, but he could only pack one type of each in each box. So that means that he could only pack one of each into every box, and he must pack the same number of CDs in each box. Okay, so I'm guessing we need to find the LCM. Yes, we need to find the LCM of the 3 numbers that are given to us. So let's do that. Oh, it looks like I shortened. Nope, there's only 3 questions. Okay, never mind. Number 2. So let's find. I'm sorry, not the LCMs, the greatest common factors, I guess. So let's find the greatest common factors of 14. So 1 times 14, of course. 2 times 7. 3 cannot go into 14. 4 cannot. 5, no. So it's just going to be 2. 2 times 7, and then 1 times 14. So let's move on to 12. 1 times 12, 2 times 6, 3 times 4, and that seems to be it, because 4 times anything, 4, we said 4 can go into it, 5 cannot, 6 can, 7 cannot, 8 cannot, 9 cannot. So yeah, these are the only ones. Let's try 8. 1 times 8 and 2 times 4. And that seems to be it. Now let's find the greatest common factors. Once again, there's 1. There's 2. And that seems to be it. So once again, everything has 1, so we're going to disregard that. And it seems like the GCF would be 2. So we would say that the greatest number of CDs that he can pack is 2. So he can pack 2 CDs in each box. And that's all I have for you guys today. I hope this video helps you guys a bit.